get started in the field, we'll just go over the scope of work for today. My name's Jennifer Dowdle, and I am a senior inspector and a materials engineer. I'm going to be the asset integrity SME on this project. So all the data that we collect in the field will be fed back remotely to myself from the various cameras and the drones back to me, so I can assess live in real time from the office for the work that's being conducted in the field. The scope of work today will basically start out first with the drones. Here's an isometric of our piping system. So we will perform the spring can survey on this piping section here. Followed, we will use the drones to perform a infrared scanning, and we'll use also the handheld FLIR unit. After the drone work is completed, we can get the rope access crew to go ahead and rig and set up the VDEC platform for access. We can go ahead and then perform the NDE from the VDEC platform for added safety, as this line is live and hot in the unit. So first, we will strip the insulation, and then we'll perform visual inspection, magnetic particle inspection using dry powder, and also ultrasonic thickness testing on the piping section and fittings. If everything looks okay from the non-destructive testing, then we can go ahead and have the crews re-insulate and de-rig and move from this location.
This is all the slack I have. So we're going to release the system.
Yeah, like it's a split screen. So you see like the actual image and then the IR. Yeah.
2 lines.
Yeah. So obviously that's where the separation is.
Yeah, a little bit of additional heat. So you can see a little bit more heat signature coming out of that separation.
Oh yeah, they're pretty hot at the dead legs. What's the temperature where it's yellow? Do you have a range there?
We don't see it on our screen, no. We would have to put it into the FLIR software afterwards to see what it is.
Okay. Oh yeah, because there's a dummy leg on that elbow, right? Yeah, okay.
Correct, yeah. Elbow looks a little warmer than the rest of the line, yeah.
Yeah, okay, so obviously it's hard to see in that, but there's a support right at that elbow, and that's why that's really hot. And the elbow's a little hotter. That makes sense.
Correct. Looks like a little bit of heat loss right where the line connects to into the big one. So that pretty good example of what the IR camera can do. It is more designed for external uses, but it has done fairly well in this circumstance here too.
It didn't look like it was sealed very well where the 1/6" line goes into the main line. And
yeah, it's an area we should send Mike to do a little bit more observation for sure.
Yeah. And obviously where it's separated there and at the dummy legs. So no other concerns, like where I don't think we need to look at any other areas than what we'd already defined in the scope. Not too bad seal. Oh, can you go on the bottom? Like below the elbow there? Yeah, okay. So the seal's kind of broken around the bottom, but there's no gaps there. What's that? Is that the bottom of that 6" line?
Yep.
Yeah, okay, where it perforates through the wall.
Yeah, and then it goes into a dead space that you can't get.
Oh yeah, okay. Okay, I mean we should check that area with when they go and do MDI.
Okay.
We'll make sure he when he does MDI, he does that whole length of that line. Yeah. And it's split on the bottom there. It's split open at the bottom, and I think you can actually just see that too visually when you're standing there. But yeah.
The chance of moisture under insulation is slim because it's inside the building.
Yeah, and it's screaming hot.
Yes.
Looks like they're about to put the big deck on.
Yeah, they got one up already that they're standing on. Now they're putting on the second.
Oh, brilliant. Looks like much more comfortable than standing on that tiny little I-beam.